Hello, 5th grade. Welcome back to the school. I'm in my classroom right now. I wish you guys were all here. It's a little bit empty without you all. But I came here so that I could show you an experiment that can be done with limiting reactants, which we learned about last time. And this is actually an experiment that you can do at home if you have all the right supplies, but it might use a few more supplies than the last few experiments had used. So if you don't have them, that's okay. You can just follow along what I'm doing in the video and make your predictions as you would a normal experiment. But if you do have the things and you would like to participate in the experiment, feel free to pause the video and go along with the experiment. You can even change it up and do it your own way if you would like. So first, I want to talk about a special reaction, one of the best known kitchen chemical reactions out there, and that is the reaction between vinegar and baking soda. I'm going to go over to my whiteboard real quick. So I have written a chemical equation up on the board. I'm hoping you guys can see it all right in the video. But I have this fancy compound, NaHCO3, which is also called sodium bicarbonate, and that is just baking soda. And I have it being added to an H+. If you remember, acids are chemicals that like to give hydrogens in chemical reactions, and it often comes in the form of an H+. It has a positive charge. So this H+ really represents the acid in vinegar. Vinegar is just acetic acid, and so I kind of simplified the equation here a little bit and just wrote the H+ that we're going to be getting from the vinegar. So we have our vinegar plus our baking soda, and that gives us three different products in this form of the equation. I have carbon dioxide, water, and a sodium ion. Now, you guys all know what water is. It's that clear liquid, and it actually looks a lot like vinegar, so we won't really be able to tell the difference between vinegar and water. Vinegar actually comes in water when you get it in a bottle. A sodium ion, that's just something that's going to be dissolved in the water at the end, so we don't need to pay attention much to that. But this guy right here, that CO2, that carbon dioxide, I want to take some time and think about that. Carbon dioxide is a gas. That is, it is air-like. So when carbon dioxide forms, it forms as bubbles. So if you've ever mixed vinegar and baking soda before, you see bubbles form, and those bubbles are the carbon dioxide. So you get all these little bubbles forming from the carbon dioxide. Now, the reason I went through all of that is so that I could tell you how this experiment is going to work. What we're going to be doing is we're going to be capturing the carbon dioxide that is formed when you mix vinegar and baking soda together. And we're going to be able to use that to tell how much reaction has taken place. So what we're going to be doing is we're going to be mixing together different amounts of baking soda and vinegar, and we're going to see how much carbon dioxide is formed. And this will help give us an understanding of how limiting reactants work. So let me show you my setup here real quick. My setup is down here. Hoping you'll be able to read that all right. There. I have 4 different water bottles. These are just normal water bottles. And with each of these water bottles, I also have a balloon. So I have a colored balloon on each one of these. This one has a red one, and we're going to have yellow here, green, and blue. It'll look kind of like a rainbow. Now, in the 3 balloons that are already on the bottles, I have put some baking soda inside of the balloon. And what's going to happen is we're going to put the balloon on the water bottle, which has vinegar in it, different amounts of vinegar. And then what we're going to do is we're going to attach the balloon to the neck of the bottle like that, so that it's entirely sealed. And then what's going to happen is when the gas forms, so when the carbon dioxide bubbles form, those bubbles aren't going to have anywhere to go except into the balloon, and they're going to fill up the balloon for us. And the balloon will fill up with the product of the chemical reaction, the carbon dioxide. And so what we can do is we can mix together different amounts of baking soda and vinegar, And based on the size of the balloons then, we can tell how much of the reaction has taken place based on how much of the product is formed. So if, say, my red balloon becomes the size of this room, we know that a lot of carbon dioxide was formed, versus if my green balloon maybe just gets about that big, it's not going to indicate a lot of chemical reaction having taken place. And so I have several different amounts of baking soda and vinegar, and I decided this beforehand, before I went into the experiment. If we were in school, we'd be testing more amounts than this, but over here with the red balloon, we have 1 cup of vinegar inside the bottle, and we have 1/4 of a tablespoon of baking soda. Now that baking soda is inside the balloon already, so when I turn the balloon upwards, it's going to dump out into the vinegar and inflate the balloon. In this second cup here, we're going to have 1 tablespoon of baking soda and 1 cup of vinegar. And I'm going to show you how to put the baking soda into a balloon here, because it's not as easy as you would think. And with a green balloon, we're going to have 1/2 of a cup of vinegar and 2 tablespoons of baking soda. And then with the blue balloon, we're going to have 1/2 of a cup of 1.5 cups of vinegar and 1 tablespoon of baking soda. Don't know if you guys can see it. There we go. Now, let me go ahead and show you real quick how I put the baking soda into the balloon. So I'm actually just going to set this down here real quick. What I'm doing when I do this is I have my baking soda already sitting here in a little tray, and I'm going to end up scooping it into a little measuring cup. Now I don't have a tablespoon measuring cup, so I'm measuring in teaspoons. I already have 2 teaspoons in here, and it should be 3 teaspoons to give me a tablespoon. And what I did is I just made a funnel out of paper. So there's a little hole down in the bottom there, and I can stick that into here. If you have a plastic funnel at home, you could use that as well. It'd be easier than a paper funnel. And then all you have to do is you're going to pour the baking soda into the top of the funnel, and it often kind of gets stuck right in the neck of the funnel, so you might have to shake it a little bit to make sure it all goes in. And then it is in your balloon and ready to go. So you don't want to turn your balloon upside down yet. You don't want to spill out your baking soda. So let me move this back up here, make sure you guys can see the experiment setup. All right, put that down just a little bit. Now, what we're going to do next is you're going to take that balloon and attach it to the top of the bottle. So you're going to stretch it out and put it over top and make sure it looks tightly sealed so that it's not going to come flying off. As fun as an explosion would be, it would be a bit messy as well. So we don't want the balloon to come flying off, sending vinegar and baking soda and water and carbon dioxide all over the place. So at this point, you can make your predictions as to which of these balloons you think will be the biggest. Is it going to be the 1 cup with 1/4 of a tablespoon of baking soda? Is it going to be 1 cup of vinegar with 1 tablespoon of baking soda? How about 2 tablespoons of baking soda, but 1/2 of a cup? Or 1.5 cups, the most vinegar out of any of them, and 1 tablespoon of baking soda? I'm going to go ahead and show you what happens. So let's start over here with the red balloon. I'm going to mix 1 cup of vinegar with 1/4 of a tablespoon of baking soda. Now, one note when you do this, you might want to hold the balloon on here just to make sure you don't accidentally pull it off. So I'm going to lift this up and I'm going to dump the baking soda into there. Actually, I'll come closer to the camera so you can see this one, see what happens. So I have this, I'm going to lift this up, dumping it in. And you see the reaction starts and my balloon is starting to inflate. Lots of carbon dioxide being formed down in there, along with water. Very nice. So that was 1/4 of a tablespoon of baking soda into 1 cup of vinegar. And you can go ahead and maybe swirl it around a little bit. Make sure you mix it all together. And that is that. Now, what I'm observing, it looks like all the baking soda is gone. Like I don't see any white particles down at the bottom. So it looks like the baking soda was probably the limiting reactant of that reaction. Now, if you remember, limiting reactant, like our sandwich analogy, is the ingredient that runs out first. So it limits how much you can make of your product. So if baking soda runs out first and there's extra vinegar left over, then baking soda was the limiting reactant. And it looks like that was the case here. But maybe it was vinegar. But a way to know would be to test different volumes and test to see which one produces the most of their product. So I'm going to stay here for these next few balloons. So this is 1 cup of vinegar to 1 tablespoon of baking soda. Notice we multiplied the baking soda by 4. So potentially we could get a balloon that's 4 times as big as that. Hopefully the balloon can take it and it won't pop. But if the vinegar is a limiting reactant, then we might not get a balloon that's 4 times as big. But let's go ahead and see what happens. Let me make sure my balloon's on tight. And here we go. Now here the vinegar came all the way up into the balloon as it's bubbling. And it is getting bigger. It is still going. So maybe it will get 4 times as big. Who knows? It's shaking. This is some good science happening right here. All right, look at that. Well, this balloon is definitely bigger than my first balloon. And I'd say it almost looks like it's about 4 times bigger. If you look at the amount of air that would be in here versus the amount of air in here, the one looks like it would, in fact, maybe be 4 times as much. My geometry students could tell you it's because it has about twice the diameter. But you have to wait till geometry to learn about all that. So I'm going to swirl this up, make sure everything is reacted. And it's looking like this is pretty clear as well. It looks like maybe baking soda was still the limiting reactant. But we can test other values to see if that was indeed the case. So let's move on to the green one. So with this one, I did something interesting. I put half the volume of vinegar in there. So I had 1/2 of a cup in my green bottle. And I have 2 tablespoons of baking soda. So I have twice as much baking soda, but half as much vinegar. So make your prediction as to what's going to happen with this one. Is it going to be twice as big as this one, half as big, the same size? Like maybe multiplying 1 by 2 and the other one by 1/2? Maybe they'll cancel each other out. Who knows? But let's go ahead and see what happens. Well, it looks like it's coming up into the balloon again. So we're getting lots of reaction happening. But it's starting to slow down a little bit. I don't know if it's going to catch up to the yellow one over there. So let's see what happens. Swirl, make sure it gets all reacted. Well, interestingly enough, it is smaller than the 1 cup to 1 tablespoon. It is slightly smaller. That is interesting. And I don't know if you can see this from there. Actually, I think you can. Notice how cloudy the green one looks. It looks kind of white. In this experiment, the baking soda did not all get used up. So the baking soda was the limiting reactant. And that's why it is still cloudy, because that white powder is still in there. So it's just mixed in with this vinegar stuff that doesn't react anymore. And lots of water in there. So you can actually, if I got close, you could see at the bottom there's actually baking soda sitting at the bottom there, because it didn't all get used up. So baking soda, or the vinegar ended up being the limiting reactant because there's plenty of baking soda. But the vinegar, because we had so little of it, we only had 1/2 of a cup, it ran out first and stopped the reaction from going as far as this one, even though we have twice as much baking soda. So now our last one over here, where we have 1.5 cups of vinegar and 1 tablespoon of baking soda. So you could think of it in several ways. You could think of it as, compared to the yellow experiment, we are adding more vinegar in the same amount of baking soda. So if vinegar was what ran out first over here, then we would expect to get a bigger balloon over here because we have more vinegar. But let's go ahead and put it in and see. Actually, before I do that, if baking soda was what ran out first, then we would expect the balloon to be the same size. So if the baking soda is bigger, then that means that the vinegar was the limiting reactant. If the balloon is, if the balloon is the same size, that means that the baking soda is the limiting reactant. I think I may have messed up a word earlier, but here we go. Oh, once again, it is coming up into the balloon. Lots of bubbles, lots of chemical reactions taking place. I don't know if you can hear it at all through the video, but it's very fizzy as well. Lots of bubbles shaking everything around. So let's see, is it going to get bigger than our yellow balloon over here? I don't know, it's looking like it's about the same size. The reaction's not done though, so it might keep going. We'll see. Shake it up, make sure it's all reacted. Still plenty of bubbles in there. So it looks to me like it's actually about the same size, maybe slightly bigger, but pretty much the same size as the yellow one. And both the yellow and the blue one are bigger than the green one then, and all three of those are bigger than the red one over here. So that was a nice, fun, and colorful way to study limiting reactants, and I hope you enjoyed it. So let's review what we learned from this. It looks like, based on what I can see, 1 cup of vinegar to 1 tablespoon of baking soda is the ideal ratio, so the right amounts of both vinegar and baking soda to get the most reaction possible. In both of these, I'm not seeing any leftover baking soda in here, so all the baking soda got used up. But when we added more vinegar, it didn't really get much bigger, so that means that almost all the vinegar was used up as well. So it looks like the 1-to-1 ratio here of 1 cup vinegar to 1 cup or 1 tablespoon of baking soda worked well. When we added more baking soda but less vinegar, we didn't get as much of a reaction because we ran out of vinegar first, and that's why we have the baking soda sitting at the bottom there. And over here, when we only had 1/4 of a tablespoon of baking soda to 1 cup of vinegar, the vinegar could have handled having more baking soda to react with. So this one didn't get very big. Anyways, this is a fun experiment you can do at home. And even if you don't have 4 water bottles and 4 balloons, but if you just have a single balloon and 1 water bottle, you can just have fun inflating a balloon using science. So I hope you enjoyed this video, and I'll see you next time.